This is an introduction to the Hypertext Transport Protocol. HTTP is an application layer protocol. It's on top of the Internet stack and usually functions on top of TCP/IP. It was developed way back in 1989 by Tim Berners-Lee. There's our stack, and the TCP is an application layer protocol there at the top. Now, originally, HTTP was very simple. It was just going to transport hypertext files to the user and show them in their browser. Things have gotten bigger. It's now the general application layer protocol to transmit all sorts of information. And we'll be seeing it used in this class not only for web pages, but for JSON data, API calls, all sorts of information being transported over HTTP. To support web browsers, most firewalls allow requests to port 80, the port that HTTP usually uses, go right through the firewall without any problem. Therefore, an application that uses port 80 will generally not have any firewall issues. If you make up your own random port number, then you might get blocked by a firewall. Basically, HTTP runs on a client-server paradigm. The server sits there waiting at a known socket port address for a client to connect. And then when a client wants to do something, it will send a message to the server, and the server will reply. Here is a general format for URL, or Universal Resource Locator. It starts on the left with the scheme, often HTTP or HTTPS. It can be like FTP for File Transport Protocol, or maybe file if you want to reference a file in your local system. Then the famous : you can put user information, although you don't see it too often. That's followed by the internet name of the computer you're going to access, like www.ncat.edu. And then optionally a colon and a port number. The default is port 80, although you can specify another port like you might use with WebGoat, where we're going colon 8080. After that, you have a slash and the file path and file name of the file on the server that you want to access. If this is a query where you're providing parameters, it'll be followed by a question mark and then a series of name and value pairs separated by an equal sign. So here we have some sort of like tag equals network, and the different values are separated by ampersands. At the very end, you can see a fragment. Sometimes you want to go to a web page, you want to go to a particular point in the web page. It might have a label. So you can go colon fragment name. In this case, it's not colon, it's going to be # top. And that means go to the web page at a particular location. If a browser is just getting a regular web page, the web page is typically written in HTML, the hypertext markup language. The HTML specifies how the page ought to be displayed on the screen, although it's generally a guideline for displaying it, and different browsers may display the same HTML document differently, which makes HTML creation all the more fun. You can characterize web documents into two different types. Static web documents are just a file on the web server that is sent back to the client when it's requested. A dynamic web document is created on the server by a program and then sent back to the user. Dynamic web documents are created by a program on the server. This program runs when you make the request, and that program creates the HTTP or HTML and sends it back to the server. This server can create a different document every time you call it. Web browsers typically use a cache. They keep the web pages that they've received recently on the disk of the computer that you're running on. Therefore, when you ask for a page, it will check first to see if it already has that page in its local file system. If it does, it will serve that. Now, pages can come with an expiration date indicating when they ought to be refreshed. And HTTP provides an if modified since option so that you can ask the server, is this page still fresh? And it will send it to you if there's a new version, or if there is not a new version, it just sends back a header saying the page that you have is still valid. When you type in a URL or click on a link in a web browser, it sends a request off to the server, and then the server will reply with a response about that web document. The HTTP request has a standard format. It starts with a method name, and I'll explain the methods in just a minute, followed by the resource. The resource is typically the file that you want to get, or the path in the file. That's followed by the HTTP version, which is typically HTTP/1.1 or 2.0 or now even 3.0. And then the next line may be various options indicating information about the request, followed by a blank line, which is 2 carriage return line feeds right after another. Here's an example. If you want to get mypage.html from the server williams.comp.ncat.edu, the request will be get space and then the file name slash mypage.html, and then if we're using HTTP 1.1, that's followed. The next line will say host, indicating what the host is. You need to have the host as a required field because sometimes a single web server is actually running from multiple websites. So you might have a commercial web server that's serving many sites, and it needs to know which site did you want to see this time. This is followed by a blank line, which means 2 end-of-line characters. Here are some of the most popular HTTP methods. The initial web system was defined to have only 3, get, head, and post, but since then several others have been added. I'll explain these in more detail. The get, which is probably the most popular HTTP method, is used to retrieve data or perhaps a HTML file from the server, although it's often used to get other data in a REST API. Head is very similar to get, but it doesn't return the body of the response. It will send the header, but not the actual data. This can be very useful if you're doing a link checker. There are programs out there that check the links in your website to make sure you don't have links that are invalid. And the link checker doesn't necessarily have to get the web page, it just wants to see if it exists. So it will send a head request to see if that web page does really exist. The HTTP put method, or put verb, adds a new resource to the server. You specify the universal resource indicator, or URL, and say, this is where I want to put this on the server, and then you pass it the text after a blank line. And that file will be uploaded to the server. If the file already exists, it will be replaced. Post is similar, but it doesn't replace the file. Instead, it adds new information to an existing resource. It's often used to submit form. If you HTML form, that data is sent with a post command. That means send it up to the server. Also, if you're adding comments or messages to a news group, you'll use the post. Don't replace the page, but add this information to the page. The delete verb does as you think. It deletes the specified resource. And patch is used to modify the existing resource. There are some debugging methods. Trace is used to get the information. It's a loopback test. It will send back the information about what you requested. And then options can be sent to find out what does this server support, what list of verbs can you use with this server. The response from the server has a standard format. It starts with the HTTP version. So it always starts with the 4 letters HTTP, then a slash, and then the HTTP version that we're using. It can be 1.1, 2.0, 3.0. That's followed by a status code, and then an explanation of that status code, which is probably unnecessary because it's always the same for a given status code. After that are some response options in the form of a keyword, data, end of line. And so there may be many response options, followed by a blank line, which is 2 end of line characters after another, and then the file contents, the information that is being returned from this request. Here's an example when I went out to my website and just got the index.html file. It returned response indicates that I'm using HTTP version 1.1, and I get the happy 200 code. It tells me what date of the file, tells me the server. I'm using the server system from Apache, version 2.4.38, and then in parentheses it tells me the operating system, Raspbian. So you should know that my web server is running on a little Raspberry Pi. Tells you when that web page was last updated. E-tag is an identifier for that. Sometimes it's a hash. Other information, the content length, how many bytes are in the page, other information. And then the content type is a text file. It's HTML. There are several status codes. Status 200 being the happy one. Got it. There's a couple others. They're sorted by groups. 100 information, 200 success, 300 is redirection. Common one is 301. This has been moved. This page is not here. It's someplace else. 400, everybody's seen the 404 file not found one. There are others. Unauthorized indicates that you haven't probably authorized yourself to get this. It's slightly different from forbidden, which means you've been authorized, but you're not allowed to get this page. And then there's the 500 errors that you get if something goes wrong on the server. It's not important to know the details of each error message. You can always look them up if you need to. If the status ain't 200 okay, you probably got a problem. Now, a web page is typically composed of multiple pages. There may be the original HTML and then several graphic files that in there. Each picture is a separate file, and the web page will be loaded as multiple files. You'll first get the HTML, and then the browser will look at that, find the individual files that are embedded in it, and make a request over HTTP to download each of the individual graphic files. Here's an example. We'll create a socket that is a web connection to the server at port 80, and then send the GET request for the HTML file you want. The server will then send the header and the contents of the file. It will typically keep the connection open. That is, the socket connection will remain open so you can request further files. Assuming that there are like graphic pictures and stuff, the client will then send another GET request for the GIF or JPEG or other graphic files that you want, and the server will send a header for that file and then the contents of that graphic files. It will repeat this for each file that exists in that web page. So if you have a page that has all sorts of advertisements and all sorts of pictures, it will go on and on and on, requesting more and more of these files. There is an issue with HTTP 1.1 or 2.0 called the head of line blocking. Because you're downloading multiple pages, if one of them has an error, if some sort of underlying problem causes a packet to be lost, TCP will correct that, but it takes time. It will time out and then figure out that a page is lost. All these downloads are occurring over the same TCP connection. So let's imagine you have an HTML file that has 10 pictures in it. So as you're downloading pictures sequentially, one after another, say the second one has some problem due to cosmic rays or some network problem, one of the packets is lost. TCP will recognize the loss because TCP guarantees delivery, and then when it times out, it will request that packet to be sent again, possibly discarding all the packets that came after the one it's missing. It'll resolve the problem, but it takes time, and therefore, while it's resolving the problem for the second file, files 3 and 10 will not be downloaded until it figures this out. HTTP version 3, which was just introduced in January of this year, attempts to correct this problem. It uses the same methods like GET and POST and stuff, the same status codes and fields as previous HTTP versions. But instead of using TCP, it uses the QUIC protocol. HTTP 3 has already been implemented in Chrome, Firefox, and Edge, and who knows, maybe some other browsers. Old Dr. Williams is keeping you up to date with the very latest stuff. The QUIC protocol was created at Google back in 2012, and it's a replacement for TCP when you want to transport web pages over HTTP, which is what Google's business is. QUIC doesn't use TCP as an underlying protocol, it uses UDP instead. UDP is a connectionless protocol, but QUIC is connection-oriented, and using UDP, it can create multiple independent channels. Therefore, if one of the channels gets slowed by a lost packet, the other channels can keep on running at full speed and display all the pictures. One of the other advantages of QUIC is it has encryption built right in. So with TCP, when you create a TCP connection, it first creates the connection, sends 3 messages back and forth to create a TCP connection. And then, if you want to use encryption, such as HTTPS, it will send another series of messages back and forth to set up the encryption. With QUIC, the encryption is built right into the messages that set up the connection. As of April 2020, about 4.2% of all websites use QUIC. The HTTP standards are defined by the Internet Engineering Task Force. There are many RFCs, which are requests for comments, but they're basically standards. And standards that are 723 something are the standards to define HTTP.